Now I'm going to explain to you how to produce a .dbc file for one or more ECM analyzers that are on the same bus. Here we have one analyzer, and if you look at the back, you see we have the EIB bus, which is connected to a module. If it was dual channel, there'd be two modules. So this is a shortened version of the EIB bus. Over there, we have a sensor simulator. Now, CAN data is sent from this analyzer out of this CAN port, which goes to a similar bus arrangement. We have these T's. You can add another analyzer here. You can build them up. You have a termination resistor. That's connected to, through this DB9 connector, to this, in this case, is a Kvisor CAN to USB adapter, which is plugged into this PC, which has the CAN adapter software and ECM's configuration tool software installed. The first thing you do is in each one of your analyzers, select what parameters you want to send via CAN from these analyzers. And you do this by setting what's on the upper and lower display and what's sent to the, assigned to the 6 analog ports on the back of the unit. So what you're going to set up is going to go on the CAN bus and also on the analog outputs. So to set the display, that's very simple. You just press these up and down arrows, and here it's green is air fuel ratio. So air fuel ratio is one parameter that's been selected. You press enter and you go down to, in this case, percentage 2. This will be a nonsense air fuel ratio number because the simulator is simulating air. So we've set 2 of the parameters that are going to be sent down the CAN bus. To send the other 6, you sys, you go into A out, A1, then you have your parameters here. I roll through them. You can go into the manual and find out what the parameters are in case you can't understand from the reading. This is phi, this is equivalence ratio, the inverse of lambda. I'm going to select that one, enter. Now it's going to ask you the 0 volt and 5 volt value. It's irrelevant as far as the CAN communication is concerned, but you have to walk through it anyhow. So I'm going to enter, okay, the 0 volt is going to be 0.04, whatever, it doesn't matter. The 5 volt is going to be 2.5 equivalence ratio. And then you do the same for A2, A3, going down here, and you set it up for A4, A5, and A6. So you've set now 2 parameters, displays, 6, so that's a 6 for the analog, that's a total of 8, plus 2 that are going to come as error codes. Then you do this in your other analyzers. After you've done that, you start up the configuration software. First thing you do is you select the Analyzers tab because you're working with analyzers now. The adapter type and baud rate you set to the correct values. Then you click Start. Alright, so what we're going to do is we're going to add a device to the list of devices for which the .dbc file is going to be produced. So, add device. Okay, fine. We go into this analyzer, we roll down to config, enter, we roll down to CAN, enter. Now it's going to ask you for the CAN IDs for the 8 parameters and 2 error codes. One ID is for 2 parameters, and which ID is associated with the parameter is explained in the manual. So let's set the first one, the ID number 1. In this case, it's 61 decimal, and you can change it to another number with the up and down arrows. Next is the second, 62, the third is 63, the fourth is 64, and the error is 65. Then click one more, and you go to this .dbc setting. Then, with this display showing please configure CAN outputs, you press the enter, you get the rolling wheel, and information that's going to be used to produce a .dbc file for these parameters is now uploaded to the software. Now this intermediate file can be saved. We click on Save List. It's saved as a text file, and I would say give this a name. This is Analyzer 1. Analyzer 1. There I would save it. You don't have to save it, but you might put together these intermediate files in different locations. Then you would you can load this file later. But in this case, if you have multiple analyzers, you go to the next analyzer, which already has the 8 parameters selected. You would click on Add Device for the second one. Go to the CAN setting. Work your way through the addresses, the 5 addresses. You must make them different for the different analyzers. And then when you get to the CAN, you press it, you get the rolling wheels, and that will be sent up. That file you can send separately. In the case if you don't, it's going to be appended to whatever you previously did. In this case, we just have the one analyzer, so our data has been uploaded. We click on Generate DBC. It's going to ask me for where to put it on the desktop, the DBC, and I'm going to call it 5220, whatever. Save. Okay, and it's I believe it's this one here. The other one will be the text file, that intermediate file. Yes, it is. Okay, so let's open this thing up. And you'll see in this DBC file some things you can understand. For example, you can see the 61, 62, 63, 64, 65 decimal addresses for the 8 pieces of data and the 2 error codes. In the case of where you have non-ECM products that are going to be sending data on this bus, you should check their DBC files to make sure that they're not using the same addresses. Of course, you'd have to change them, and then you'll have to append the files, the DBC file produced for this software for ECM's analyzers with the DBC file from the non-ECM products. Kick out of here. And that's about all you need to know. The second stage, taking the data, taking the DBC file and using it to import data into ATI's Vision product and ETOS's Inca product, is explained in 2 appendices in the instruction manual. You can do the same for VectorCAN and other products. The procedure is very similar. Thank you.